Okay, a 7-digit telephone number is in the form of ABC-DEFG. In one state, the digit A is restricted to any number between 1 and 9. The digits B and C are restricted to any number between 2 and 9. And digits D, E, F, and G have no restriction. How many 7-digit phone numbers are possible with these restrictions? Okay, so this is a typical problem like this, right? Because you can't have two people with the same phone number, correct? So just interesting enough, why would the first number be 1 through 9 and not 0 through 9? Because the first number you dial can't be 0, right? Get the operator back in the day, right? So they limit it 1 through 9. So how many numbers are there between 1 and 9? Total. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, right? So there's 9 different numbers it can be, 1 through 9, right? But the B, so this is what you do. You go A, B, C, and then D, E, F, G. And what we're basically going to do is we're going to figure out how many possibilities there are for each one, and then we're going to multiply. Fundamental counting principle. So A has 9 different choices, right? Now B can be any number between 2 and 9. How many numbers is that? So I'm going to show you a little way to do it. What you do is you take the bigger number, 9 and 2, you subtract. 9 minus 2 is 7, and then you add one more. So 1 through 9, 9 minus 1 is 8, and one more is 9. Because just the example of this. When you count from 1 to 9, if you start at 1, you go 2, 3, 4, 5, 6, 7, 8, 9. You're only going to get 8 because you don't count that first number you start at. Right? So, like 0 through 9, that's 10 numbers. But usually you would count, you wouldn't say 0, you just go 1, 2, 3, 4, 5. So that's the way you do it. And you say, okay, so if I ask you how many numbers are between 23 and 50? A little harder, right? But if you just subtract, 50 minus 23 is 27, and then we add 1, there's 28 numbers to choose from. Okay, so remember now, what we're doing on this is we're figuring out how many numbers can be in each one. So A was 9. Now B is between 2 and 9. 9 minus 2 is 7, and one more is 8. All right, and B or C. So here's C. C is also 8, correct? And then what are the rest of the numbers? There's no restriction. So one of the ways I always trick my students back in the day would say, okay, when I teach place value, I would say, okay, there are 10 single-digit numbers, but there are 10 single-digit numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? Anybody? Put you to sleep, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, and? 10. Not 10 because it's 2 digits. So it's 0. Yeah, it's 0. So 0 through 9 is 10 digits. Well, 9 minus 0 is 9. We add one more, it's 10, right? So if there's no restriction, that means there are 10 numbers for each of those. So then, what you have to do is just multiply all these numbers. And that's why you got the calculator, okay? So go ahead and multiply those numbers together. Yeah, and I'll come by and just look at it on your, I'm sorry? That's 9. I'm sorry, that's a 9. 9 times 8 times 8 times 10 times 10 times 10 times 10. Somebody's got it on the calculator. You got it? Five, 7, 6, 0, 0, 0, 0. You got that? Okay, good. So 5, 7, 6, Now, how do you pronounce that number? The key is this. All right. This is why we gotta start at the right, and we go 3 digits, we put a comma, 3 more, and we put a comma. Now, we take whatever numbers in between the commas, and we just, after we say it, we say what it represents. So these are hundreds, this is thousands, this is millions. So it's 5,760,000, and then there's nothing there. So that number would be pronounced 5,760,000. Got it? All right, so here we go. 5, 8, 2, 9, 6, 5, 3, 4, 2. What's that number? So we got to do this. Comma, comma. Let's add another number. So this is hundreds, thousands, millions, billions. So who's going to take a shot at it? 4 billion 582,965,340. Got it? So you have to pronounce that part right in between. Anyway, so this was the answer, the 5,600,000.